Hello everyone, welcome to TriRide, the new era of learning. Myself Rafiq. Today we're discussing about recurrent neural networks and long short-term memory. Okay, so yesterday's videos we discussed about RNN, right? Recurrent neural networks. I explained in deeply. If you don't see that, once check out the video. And in that video also, I explained a little bit about RNN, and after that I move to the LSG, right? Okay, so let's come to the point. Let's come to the point. First, we discuss about RNN with compared to the LST. Oh, sorry, with LST. Okay, so an RNN is a type of neural network designed for sequential data. Unlike regular neural networks, RNN remembers previous inputs using an internal memory, which is idea for the task. Task is like we all know the RNN task performs like language modeling, time series and predictions and speech recognitions and music generations, right? Okay. And so why recurrent neural networks? We say since common points here I suggest here. So human does not start their thinking from scratch every second, right? Human doesn't think from the scratch each every second, right? As you read it this easy, you understand each word based on your understanding of previous words, right? You do not throw everything always and start thinking from the scratch again. Not all problems can be converted into one with fixed length input or outputs, right? Problems such as speech recognition and time series predictions requires a system to store and use context information. It is unclear how a traditional neural networks could use its reasoning about previously to inform later ones. So now comes into the picture RNN. RNN is address. Okay, recurrent neural network takes a previous output or hidden state as input. Right, the composite input at time t has some historical information about the happening at the time t. Right. So what is saying that little bit inconvenience with RNN. Okay, that's why they introduced the LSTM. Okay, so in the diagram, a chunk of neural network, it looks at the same input xt and output has a value at ht. A loop allowed information to be passed from one step of the network to the next, right? It is a loop based. So a unrolled recurrent network, a unrolled RNN, right? So if you see the loop of xt, it has n number of up to the loop, right? We see the in many to many concept like this. So how many inputs do you have? That measure based on inputs, you have the based on outputs. It's stuck in a base of a loop. So actual structure of RNN is like this, the first diagram. So it iterated in loop. When we unrolled the roots, we see the layered based structure of like this of RNN, right? So in this we use vanishing guardian and exploding lot of things we use in it. So well by the way we also discuss about that. So here we can think RNN offers a lot of flexibility, right? We have one to one, one to many, many to one, many to many. Like that we has a lot of flexibilities here. So first one to one for vanilla neutral neural networks we called as VNN. Each rectangle is a vector of an arrows represent the functions. Okay. So next to one to many, we use the image captioning. Okay. For many to one, we use so say sentiment classification. I used to said yesterday's videos. When we take some review, the movie is nice. We predict some sentiment. We predict some stars, right? Like sentiment analysis from many to many we use machine translation like sequence words like we use some many to many words we like yesterday's videos we take as Rahul by a new iPhone like that we take some sequence from an RNN sequence words. Okay, so in also we take another classification as video classification on one frame level. So RNN output usually want to predict a vector at some time of steps, okay? At the time of steps. So RNN works about the it is defining the diagram. Output is defined usually predict some values based on your input values. So here what's the RNN layers do? We can process a sequence of vector X by applying a recurrence formula at the every time step. Okay, HT equal to FW, HT minus 1 by XT is the formula based. So some functions and some set of parameters are used to every time step. Okay. And what is vanilla RNN? Vanilla RNN state consists of a single hidden vector layer, which is rolled in a loop, right? Which is rolled in a loop. So here's the formula we used to check the vanilla RNN. It was single output, which used to one output, one input, right? One to one. So what is backpropagation used for? Is used for so backpropagation usually used for treat the unfolded network has one big feed forward network and compute guidance to the usual backpropagations, update shared weight, and we are example sentiment classification. We also know that sentiment classification classifying a review from a helps or movie review from the IMDb like has positive or negative inputs. If you take one input has one or more sentimental consisting of multiple words like positive negative classification, like so that the food is has a really good, it has a fantastic movie like it is a good in that and fantastic it depends on sentimental analysis. You see, check the sentimental like I want to go to the if excellent action movie like you consider the action the movie was such a great like you consider great the movie was fabulous content like the content are fabulous like the sentiment analysis triggers your emotions, right? Triggers your happy and emotions. Okay, it considers the emotion based. So sentiment analysis classification work like if you first change your words into a vector, right? Embedding and then feed into a RNN, right? Then I said that the food is good, so the food good like that is classified. If the food like takes the good, the income. So we think as the food is such a good in the restaurant, like it takes like that. The RNN has received a sequence of vector as input and consider the order of the vector to the generated prediction. And sentiment classification, we are using the segmented because we are trying to predict if text has positive or negative sentiments. We don't care about the sigmoid outputs expect from the very last one. We can ignore the rest. We'll have to calculate the cost from the output of the last step. And the training label like positive and negative like if you consider as image captioning, we can see the view an image generate a sentence describing its content, right? We use in most in content moderator in content generator. So we text image into that. It starts with some said old man wearing with a hat, like a old man wearing a hat, it's colored brown, like the sentence image captioning like that we use. So RNN language model it use shows. So problem of the long term depends on if we are trying to predict the last word in the clouds or like the clouds or in the sky. We don't need to any further context. It's tricky. Observe pretty obviously the next word going to be the sky, right? So like this, it will be works. So we have some little issues with that. So the problem is what means, but there are also cases where we need to more context consider trying to predict the last word in the text. Like I grew up in France. I grew up in France. I speak fluent French. Like it takes some. I grew up in France and I speak fluent in France. Like there is considering the words, some getting trigger x0, x1, x2, like up to xt and t plus 1 and h plus t. Like in some words, it gets out in the getting the output, it some gets some little bit same frequency, right? So for that to come the output, we use the it's some little bit it's from the past information. Like we have the long term and we have the short term. It doesn't recognize the some words from the stored, okay, from the previous stored, okay. So in the theory, RNN are absolutely capable of the handling such long term dependence, right? So sadly in practice, RNN does not seem to be able to learn them, right? So vanishing, exploding guardian. In the same way, a product of the k real number can shrink to zero or explode to infinity, right? Either they become to zero or explode to the infinity, uncountable. So can a product of matrix for large value of W, the gradients will grow exponentially with the time, and for very small value of W, the gradient will shrink exponentially with time, vanishing. So LST does not have this problem. The one what is LSD? Long-term, short-term memory networks, usually just called LSTMs, or specially kind of RNN capable of learning long-term dependency. So it's specially kind of RNN that solves the problems by introducing gates to control the information flow. So the cell structure is nothing, but we have some cell structure, the memory of the network and handling current state, the output of the cell and input gate decide what new info it add, and forget gate decide what info to be discharged, and output gate. We have three gates: input, forget, output. Okay. We have two states: cell state and hidden state. So long short-term memory, the network or modified version of recurrent neural networks, which makes it easier to remember the past data in memory. That vanishing gradient problems of RNN is resolved here. So LSTM is well suited to classify, process, and predict time series. Given the lacks of unknown duration, it trains the model by using backpropagation. In an LSTM networks, three gates are presented, right? So what is the gate one input we call as input gate? It discovers the value from input should be used to modify the memory, right? Sigmund function decides which value to let to be through 0, 1, and tan h function gives the weightage to the value which are passed, deciding the level of the importance ranging from -1 to the +1. This is the formula of the input gate one which we consider here. So in that terms, we take h minus 1 and add the term again by using tan value. So what the function block of forget get? It discovers the details to be discharged from the block. It is decided by the sigmoid function. It looks at the previous state like ht minus 1 and the content input xt and output number between the 0 omits limits this and keep this from the one and one keep this for each number in the cell state, right? CT minus one, like it uses the cell state to didn't forget the if the state is okay, it moves with it continues with the state. If the state is unlabeled or a little bit unconducted, unconsidered, so it leaves that state. So output gate handles the inputs and the memory of the blocks is used to decide the output. So sigmoid function decide which value of to let to the 0 and 1 and tan h function. Use the weightage to the values which are passed deciding the levels and importance ranging from -1 to 1 and multiplied with the output of segments, right? This is the formula of the output gate. And in standard RNN, the repeating modules will have a very simple structure such as single tan H layer, right? The repeated the module in the standard RNN contains a single layer. We can see here we have A and A. We have the tan H of a single layer. We consider it is nothing but the tan H is the middle term of the 0, where the xt1 is the +1 is a positive term of A, and it is a ht minus 1 is negative term of -1. So you're considering LST long short-term memories are also have a chain like structure, but the repeating modules has different structure. And instead of having a single neural network, there are four interacting in a very special way, right? It repeats module in LSTM content from what interacting layers. Okay, and LSTM doesn't have ability to remove or add information to the cell state carefully regulated by the structure called gates. Okay, gates are a ways of optionally let information through. So the forget gate usually we explain the forget gates are always optimally let information through. Right, this is the formula of the forget gate. The loop one of the forget gate. If the iteration will done, it will the okay. It will move to the tan edge. Otherwise, it moves to the output gate. And when the input gate enters some value, it remains the calculated with tan, and sigmoid release the values to the output. And here the direct output gate means if the value is properly uncontrolled, the sigma gate allows the tan h and the alpha to directly to the output. Summary: RNN are widely used model for sequential data, including text, and RNN are trainable with backpropagation. RNN learns complex and varied patterns in sequential data. Vanilla RNNs are simple but don't work very well. Backward flow of the guardian of in RNN can explode or vanish. Common to users LST and GRU memory path makes them stable along long distance interactions. So I hope you guys you understand about the RNN LST about RNN and the LSTM method. So thank you for this.